Hello everyone. In this video, we are going to see an important and advanced surveying equipment called as RTK DGPS. First of all, what is GPS? GPS stands for Global Positioning System. We all know that Earth is surrounded by man-made satellites as well as natural satellites. Now the function of this man-made satellite is that it will continuously send signals to the Earth. Earth is orbited by this network of artificial satellites, and the information contained by these signals are two informations. One is timing information and location information. Both these data will be continuously sent by the satellites. Next we will see about the receivers. So what is the function of receiver? The receiver will continuously receive the signals from at least 4 satellites, and with the help of these signals a GPS receiver can calculate the exact position on Earth's surface. However, due to factors like atmospheric interference and satellite errors, there is a problem with accuracy. That's where DGPS comes in. DGPS means Differential Global Positioning System. A difference between GPS and DGPS is that a DGPS enhances the GPS accuracy by providing correction signals from fixed base station to GPS receiver. However, for tasks requiring even higher precision, there is RTK DGPS. So what is RTK DGPS? RTK means real-time kinematic, DGPS means differential global positioning system. So it takes the precision to the next level. Why? Because it achieves centimeter level accuracy in real-time applications. Now we will see the components of RTK DGPS in detail. RTK DGPS has three important components. One is base station, and we have this rover receiver and a controller. So this controller's function is to control both this base station as well as rover receiver. This is just like a mobile phone. You can see here, you can make calls, we can insert SIM cards, we have a camera as well. All the features in the mobile phone will be available in this controller. So in this device, the base station plays a critical role as the reference point for the entire system. Now we will see the components of this base station very detailedly. The base station consists of a GNSS receiver. Now this is called as the GNSS receiver. It locates at the heart of the base station, and it is a high precision GNSS receiver. This receiver continuously tracks signals from GPS, GLONASS, Galileo or other satellite constellations to determine its own precious position. Next we have this antenna. Now this one is called as the antenna. A high quality antenna is very important for optimal reception of satellite signals.
So we can see the bottom of the base station. It consists of a tripod here, and you can see the tri badge available here, and here it is the focus lens for centering, and you can see the level screws for here. Then you can see the split level, so which is used for centering and leveling. So at the bottom of the tripod you can see the accessory for centering purpose.
There are many models in RTK DGPS like Trimble, but today we are going to see this KRYPTON model. To switch on this base station, you have to long press on this power button. You can see here a green light. So the green light represents battery. The device is switched on, and we have a Bluetooth connectivity. And for taking the points, this first option is the one which helps to identify that whether we are receiving the satellite signal or not. If you keenly watch that, once switching on the power button, after some 1 minute, this satellite option will appear in green color. You can see the green color blinking option, which means we are receiving the satellite signals. And one more important information is that a base station should be always placed at a clear open skied place. Why? Because then only you can easily get the satellite signals properly.
So the first step is we have to connect this controller with the base station. So you can see here this controller, I'm just switching on the power button here available. So just I'm moving on. So you can see here there is an app named Nuwa, NUWA. So this app is also available in the Google Play Store. You can download it in your mobile phone also, and you can use it as a controller in your mobile phone also. So I'm just opening this Nuwa app here. Just give cancel. So this Nuwa app has four icons here. You can see the first one is project menu. In that project menu, you can see here project CRS, that is coordinate reference system, code, point, line, road, and export and import facilities also available here. Then the settings tab, cloud settings, and more. So moving on to next icon, that is a device menu. So you can see in the device menu, you can see connect option is available, data terminal, base station is available. You can connect with the rover, then NMEA output, device, tab, and more facilities also available here. Then moving on to the survey tab, survey menu. So survey option is available, points takeout, lines takeout, static survey, site calibration, survey configuration, base shift, roads takeout, surface takeout, then CAD takeout, that is CAD takeout, then more options available. Then moving on to a tools icon, tools menu, area perimeter, azimuth distance, so these things can be done. Then offset point, rotation point, 2-point intersection, 4-point intersection, intersection angle, earthwork, angular bisector, grid to ground, one minute, grid to ground, line segmentation, points average, then parameters, then more facilities are available.
Before creating any survey operation, we need to create a new project. For creating a new project, click on this project option, and we have an option called new. Select this new, and it will ask you for the project's name. You can enter the project name. I will type here as ETA, and the creator name will give it as ABC. By default, it will update the creation date, and we have the coordinate system and all other information. Just click OK. Now a new project will be created. Now a new project is created named as ETA. If you want to open a previously worked project, you can see here in the options, the previously worked options will be available. Now we have successfully created a project called as ETA. We will make changes to the coordinate reference system if needed. Click this CRS. CRS means coordinate reference system, and WGS 1984, which stands for World Geodetic System. If you want to make changes, click this edit option. Now currently we are in Chennai, so the zone is 44 north. If you are in some other location, based upon the location, you can change the zone and the hemisphere. Now we are going to connect this controller with the base station. For doing this, you can click on this device option and click this connect. You can see the device type, name of the device, which is Oscar, and connect type. We have two options. You can either connect with the help of USB or else Bluetooth. Now we are going to connect by Bluetooth, and this is the name of the receiver, number of the receiver, the serial number is displayed here. Now we are going to connect this. Click connect. You can see here the device has started to connect, and it is successfully connected. In this base station, the Bluetooth signal is on, so both this base station as well as this controller is now connected. You can see here the Bluetooth light is in green color, which represents both these devices are connected.
Okay, so far we have seen how the base has been connected. So this controller and the base has been connected successfully. Then we are moving. Then we are going to connect the controller with the rover unit. So for that, you can see after connecting successfully, you can see an icon called stop base. You should not touch that. Just go back, and in this connect option, you can see this controller is connected through Bluetooth to the base unit. So we have to first disconnect this one, then we have to connect the controller with the rover unit through Bluetooth. So we have to first disconnect this controller and base unit Bluetooth connection. So just give disconnect. Now you can see that we have to go to connect configuration. So 303 is the base unit serial number, 305 is the rover unit serial number. So we can now just give connect. So before that you have to switch on the rover unit. So you can see here the rover unit is switched on. It will establish the satellite connection. It will establish the satellite connection now. So you can see the satellite is connected. The Bluetooth is not connected. We can just now connect the controller with the Bluetooth. So we are just given the serial number of the rover unit. Just click on connect. It is trying to connect. So you can see the Bluetooth is also connected with the rover unit. So similar to the base unit, the rover unit is also connected with the controller. So then we are going to say that this portion is the rover unit. So just click on the rover. You can see the status, link status. Okay, so just give back. Now just give connect. You can see here. Okay, so far we have connected the controller and the rover unit through Bluetooth connection. So you can see how it is verified. So you can see that 305 serial number is the rover unit serial number. So we have connected this controller with the rover unit. Then we have to configure this rover unit with the controller. So just click on the rover. You can see these values are available. So this TCS, those are connected through the SIM card or the network. Okay, so now we are going to connect to the radio. Just click on the radio, internal radio, then give detail. Just select detail. You can see these values are available. So you can see the protocol also. So all these are default values. Just click on OK. Then just click on start. Configure rover successfully. So you can see the rover is configured successfully with this controller. So it is evident here. You can see that up arrow, upside arrow and down arrow is blinking in green color, and at the left side you can see the point is fixed. So using this you can start the project work. So we have configured the rover successfully with the controller. So then we are moving on to the project. So you can see we can fix the points now. Before that we have to fix the height of the rover unit. So you can see the height of the rover unit. So this is a rover unit. So it is mounted on a pole. You can see the pole height is 2 meters. So the rover is mounted on the pole at a height from 2 meter distance. So mostly 2 meter is fixed. So it can also be varied according to the land conditions. So 2 meter. So the antenna height. So this rover unit has an antenna here. So this height should be fixed based on the pole. So this is, you can put 2 meter here. 2.0. Okay. So the antenna height has been inscribed as 2 meter. Okay. So just click on the new project. project new, and just click to, then just okay. So new project is created. Okay, so new project is created. So in this new project we are going to work. So just click on, you can see the new project is created here. Now click on survey, we are going to survey. So in this survey, just click on the survey. So you can, we are going to see the points now. Okay, so before placing the point, we are going to see the rover unit split level. You can see here the split level. So when the split level is placed at this center, you can see at the left side it shows in green color. So if the split level is moved, you can see it is showing in red color. So the person whoever is carrying the rover unit should ensure that the split level bubble is placed at the center. So once the person with controller sees the green color signal, then they can click on the location. So after clicking on the location, you can see we have obtained the values of northeast and the height is 1.917 meters. So this height is from the mean sea level. So you can see here the base station is placed here, and from the base station you can see the rover unit is placed here, and the split level has been maintained at the center, and using that a point has been fixed. So this base station height is subtracted and this rover unit height is subtracted, that is the antenna height is already input. So those things are subtracted from the ground station point wherever it is available, then it is giving this value. This is 1.9717 meter, which is from the mean sea level. So just click on OK. So a point has been added. So you can see the person is moving this rover unit to another point. So he has moved to another point. Then he has ensured that the split level bubble is placed at the center. So once you see it is blinking green, just click on the location. You can see another point is placed. That point is at a height of 1.9223 meter from the mean sea level. The northing is value is also available. Just click on OK. Another point, that is point 2, has been created. So similarly, you can see a area can be covered, and the areas can be obtained for the levels. So next third point is placed. Just click on the location once you see the green signal. So point is obtained, just click on OK. So third point is also placed. The person has moved with the rover unit for the fourth point. Just click on the location. So once you see the green signal on the split level, you can see point has been obtained, that is a point 4. It's just a very simple process. So like this, point has been obtained. You can see the person has completed the area, just a rectangular area we have surveyed for example. So the 4 points has been noted. So to see the values of the 4 points, just click on survey. You can see a text option is available, just click on that. Then you can see points option is available at the bottom left corner, just click on that. You can see the values of the points are available. Base station is available, then point 1 2 3 4 detail is available, then the northing easting values of the base station and the 4 points are available. You can see the height also available. So the base station we have given WGS 1984, so it is representing minus 89.9820. Other 4 values we have given in north Nothing is height, that is the UTM values, universal transverse Mercator value. So it is represented as like that. Then you can see the latitude longitude values also available here. Height values according to WGS 1984 also available. The collection time is also available here. So there is one more option above the location point. You can see edit option available. Just click on the edit option. So you can see polyline, polygon, square, diagonal, square, center, rectangle, rectangle, center, circle, circle. So available. You can just click on polygon. Just you can give the line name and code. Then just click on OK. These things can also be done here. So we have seen the values of 4 different points on the base station. We can export those values. You can see here. Just click on export. So the first one is coordinate export, then other export is available. So in this coordinate export, you can see, just click on all the values available. Just click on detail. Yes, you need all values. Just click on all the values. Yes, so all those values are selected. Then the format we are going to select is name, code, and not teaching height. Then the file name, you can give any file name which you want. You can see the storage part is available. Just click on export. So before that, I will explain the other export. You can see here one. So you can see, you can also select the file format which you want. So the already existing file format is KML. You can also see shapefile. This point coordinates can be also exported as a shapefile, also SHP. Then all the file formats DXF, HTML, XML. So these are the file formats available. So we are going to take it in the KML file. You can also export it as a shape file, and you can use it for a ArcGIS, QGIS, or Google Earth Engine purpose. Now I'm going to export it as KML. Just say the file name, then just click on export. I'll show this other export first. Just click on export, click on share. You can see these are the options available. So one minute. So you can see the Bluetooth. If this controller is connected with the internet, you can also mail. You can save to drive. Mostly will be sharing with nearby share. So you can connect this one with the other phone or other devices available. So then this exporter file can be used for mapping purposes and other utilities.